Hello everyone, welcome back to Risha Education. So we were doing chapter 2 of Gallian and we have already done 35 questions in 5 question series. So basically 7 videos have been uploaded. You can go and check that out. Next I'm going to do is this is my 8th video in which we will cover 36 to 40 questions. So let's get started. So here the question is saying that let A and B belong to a group G. So A and B are belonging to the same group G, and we have to find X such that this is satisfied. We have to find an X. Basically, we have to find one X. We need not to find many X. There could be an option where more than one option is correct for this, but we have to find only one such X. So we will be focusing on that only. So what I do first, I remove X inverse from here. So what I get is XAB equals to BAX. Now you can see from here, it's AB, it's AX, but here it's XA and it's BA. So clearly, if you notices what is there, B is equals to X from both the side, you can notice can be one solution. Why? Because if you put B in that, you get BAB is equals to BAB. And yes, this is true in a group. So that is why you can say that B is equals to X is one of the such solutions. So next 37, we have a finite group G. So G is basically finite. We have to show the number of elements X of G so that the number of elements of X of G such that X cube is equals to identity. Okay, we have to find X in which this is satisfied and the number of such X will be odd. Okay, so whenever you see these type of question, what first comes to your mind that whether the identity is satisfying the property or not. So clearly E cube is equals to identity. Hence, if I say S to be such set, then E will be one of the element. And suppose I take any one element X, then I will like to see whether is there anything which also is satisfied. So if X is in the set, that means X cube is equals to identity. So if X cube is equals to identity, you can see that X inverse whole cube is identity. Here I would like to add on one thing. These works on the property of the order of a group basically and order of an element. In further chapters, you will read order of an element, but for now you can see that this works. Okay, whenever X cube is identity, X inverse cube is identity. Why is this happening? Just multiply with X inverse whole cube both the side. And here you will get the identity and here it will be the same. So whenever you have an X, you also have an X inverse. Similarly, whenever you have an Y, you have Y inverse, and similarly it goes on. So from here you will notice that we have 2k elements, and for identity we have plus 1 elements. So in S set we have basically 2k plus 1 elements. Depending upon the group, this k will vary. Okay, so suppose in U8, okay, not U8, here X cube is equals to identity. Okay, so you find an example. I'm not able to crack it right now, but yeah, it will be 2k plus 1. This is the idea basically. So if, yeah, I got an example. So Z3, in Z3 what we have? We have 0, 1, 2. In addition, so if you see 0 cube, it's 0. If you see 1 cube, it's 1 plus 1 plus 1, basically 3, which is also equals to 0. And if you see 2 cube, it's again 0. So as you can see, the S becomes 3 here. So cardinality of S becomes 3 here. So this is the thing you need to know, that this is odd in nature. And why this is odd? Because of these things. Similarly, you have to show that the number of elements X such that X square is not equals to identity is even. Now, again, for identity, identity does not belongs to the set. Suppose I consider this set as X. Then identity does not belongs to X. Now, what happens when x belongs to x? Then x square is not equals to identity. And this will imply that x inverse square is not equals to identity. Suppose if this was not the case and x inverse is square, we got identity, then what we can do is we can multiply with x square and we would have got x square is equals to identity. But we have already considered that x square is not equals to identity. Hence, this assumption is also wrong. So x inverse square must not be equal to identity. And whenever x belongs to x, x inverse also belongs to x. Okay. And from here, what you can say is again by this paired formula or by here the pairing formula, x have only 2k elements. K will differ by the difference of the group. What group we are choosing, that will differ. So next 38 number question. This is an interesting question. We have to find an example of group with elements A, B, C, D and X such that AXB is equals to CXD, but AB will not be equals to CD. So we will try to find the example in D3. Okay. So in D3, what I have done, I have made triangles and I have considered one rotation and one reflection. So this is reflection along first, and this is rotation along, you can say via anticlockwise. Now what happens, I will consider A as R120 and B also as R120, and I will consider C as identity and D as well as identity. And I will consider X is equals to F1. The only thing that you have to do is to set everything. Now what happens to R120? So I am finding AXB here. So it's R120, F1, R120. So what happens to, first of all, I'll do R120. And then when I do F1 here, it gives you 3, 2, 1. So basically, it give you R240, sorry, F2. It's F2 actually. So this is F2. So these two will give you F2. Now R120 and F2. So R120 and F2, suppose you apply F2 here. Then what happens? You will get 2 and 3 here. Okay. If you do this, so first you have to apply F2. So this is triangle 1, 2, 3. You have to apply F2 first. So what we get? We get 3, 1 and 2. And now you have to apply R120 here. So what you get is 1, 2, 3. So this is, oh sorry, 1, 3, 2. So this is basically F1. So you get F1 from here. And now when you do CXD, you have E F1E, which is equals to F1. So from here, you can clearly say that AXB equals to CXD. Now we have to say AB and CD. So what is AB? It's R120 and R120. What is this? It's basically R240. And if you do CD, you have CD as E times E, which is equals to identity. Or you can say this as R0. And this is not equal. So we have able to find an example in D3 like this. You can even find in D4 or any other group. Next, 39. What this says that G be a property such that AXB equals to CXD. If this is the case, this implies AB equals to CD. And what we have to show that if this condition holds in a group, then G is abelian. So G is abelian basically. So we have to show that AB is equals to BL. So one thing I would like to say that these are just a setting up the questions. Basically, you have to think of something and you just have to set everything in such a way that this implies. Now what I did is A is equals to A I consider. And I also know that from wherever side I multiply with the identity, it will remain the same. So E is equals to AE. Now what is E? Identity. So identity is basically, I can write it as BB inverse. And even I can write as B inverse B. Why I have written in such a way? So that my middle terms gets cancelled and I get what I want. Now I arrive at this. So basically I arrive at B inverse A is equals to B inverse B. Now I will apply this property. I will cancel out X and I will get BA is equals to AB. Now you can see how beautifully I have came to show that G is abelian. Okay, so that is what here it says, that if the middle cancellation is applied, if I am able to cut the middle elements, then this implies commutativity of the group. Okay, next come to the 40, that is the last question. We have to find X in D4 such that R90 V X H is equals to D dash. Now D dash is along another diagonal, H is horizontal flip, V is vertical flip, and R90 is basically rotation by 90 degrees. So what I did is basically I will multiply H inverse to both the left, to the right. So I get D inverse dash H inverse. Now I will multiply by R90 inverse. So I will be getting R90 inverse D dash H inverse. Again, this is X. So this is X again by V inverse to the left. So we have V inverse, R90 inverse, D dash and H inverse. Now this is the X we required. Now we have to solve it. So what is V inverse is V. R90 inverse is R270. D dash is D dash and H inverse is H. So start doing from the backward. We get these two as R90. So we write V R270 R90. Now these two is R360, which is equals to R0, and these two will give you V. So X is equals to V will work here. And I hope you understand this. We came to the end of the video and thanks for watching. If you like the video, please share and subscribe.